All right. Good morning, everyone. My name is Melissa Tui, and I'm the EdTech and Adoption Specialist here at Ozobot. This morning, we are going to cover ShapeTracer 2. We're going to give you some tools to help your students with computer science and give them some opportunities to engage with computer science in this time where a lot of us are not in traditional school settings. So we're going to go ahead and get started. This is our agenda for today. We're going to go over we're going to do intros of myself, who will be hosting the webinar, and we have Lisa Richardson, who is an educator from Texas, and she's going to introduce herself in just a minute. We will also go over some housekeeping items about Zoom and just how to use and engage in our webinar today. Then we'll walk through ShapeTracer 2. Then Lisa's going to share all her wonderful recommendations for how to implement this. I saw her slides. She has some amazing content. It's really practical and applicable, so I'm really excited for her to share. And then we'll finish with Q&A. So to get started, we'll go ahead and introduce ourselves. Lisa, would you like to go ahead and introduce yourself?
Sure. Hi, I'm Lisa Richardson. I am from the Houston area. Actually, my school is in Friendswood. I teach at Clear Brook High School. So I actually teach high school math and have implemented this in our distance learning just in the last several weeks. So kind of showing you guys, when you've never done something like this, how you can just go on ahead and make it applicable in your class.
Thanks so much, Lisa. And again, my name is Melissa. I am a former founding teacher. I founded a school where I was the coding, engineering, and design thinking teacher. I also have been a computer science coach and just a generic kindergarten and first grade teacher. So standard first and kindergarten teacher. I'm also currently in UCLA's educational leadership program pursuing my doctorate. So I'm all about computer science and getting more kids to engage in computer science. That is my passion, and I'm so thrilled to be here with you today. Just some best practices for our protocol today. If you are following along and you'd like to actually do ShapeTracer as I'm showing it to you, what I recommend is opening up a new browser window and having a side-by-side of ShapeTracer and my screen, so you can actually see my screen and follow along while doing ShapeTracer yourself. If that's not an option for you, or if the pace is too fast, we will have a recording of this up on our YouTube channel. And if you've opted in for updates from Ozobot, you'll be emailed a video recording of this so that you can go back and complete ShapeTracer 2 at your own pace. So, but I do encourage you to follow along if it's something that's helpful for you in your learning style. You are automatically muted, so again, if you have any questions, please list it in the chat or that Q&A. And I said this already, but yes, if it's too fast for you, a recording will be made available. Oh, we did the poll already. And now we are going to jump into a quick video about Ozobot's 2 ways to code. So if you're not familiar with our 2 ways, this is a really great introductory video for you. Great, so I hope that gives you a little insight into what the capabilities of the bot are. Again, we have 2 ways to code. We have our color codes and Ozoblockly. Today, we're gonna focus on Ozoblockly and ShapeTracer in particular. I know a lot of you are in situations where your students may not have had the opportunity to take bots home or engage with robots. So this is the perfect opportunity to continue to deliver computer science instruction without needing a bot. So I know a few people have asked about where ShapeTracer is. I'm going to go over that with you right now. I'm going to actually share a different screen. So if you are on the Ozobot website, if you go to ozobot.com, what you need to do is click on Create up here at the top. Once that loads, ooh, hopefully it loads. I think all of us are probably trying to get there. Once you click on Create, if you click to Games right here at the top as well, this will take you to a new page with both our ShapeTracers. And I think all of us are trying to get on, so it's taking a little bit for this to load.
I will say for your students, you can copy the link directly to ShapeTracer, and it does work for the kids. So instead of having to give them the breadcrumb to get there, definitely the link will take them right there, and it's not going to mess up any saved or take anybody else's answers or anything.
That's great. Thanks for that suggestion. So once you click on games, if you scroll all the way down, or about halfway down, you'll see ShapeTracer 1. We actually did a webinar on ShapeTracer 1 a few weeks ago. If you're interested in that content, visit our webinar page or our YouTube page to follow that webinar and to view that webinar. Today, we're focusing on ShapeTracer 2. So again, you're going to go to ozobot.com, click on Create. When you click on Create, there will be a Games option. Click on Games. It'll take you right here, and we're going to jump into ShapeTracer 2 by clicking on this arrow. So once we get started, what we're going to do is I'm actually going to walk you through every single level of ShapeTracer, and afterwards Lisa's going to give her suggestions of how to actually implement this, and she's going to chime in with her recommendations as well for instruction. So I'll be giving instructional tips and just going over the basic ideas of how to complete each level of ShapeTracer. So I'm going to stop right there because I do want to share a few tips and tricks before we jump in. And Lisa, feel free to offer suggestions as well. But a lot of you might be wondering, okay, I don't have students in front of me. This is super untraditional. I'm not really sure how to teach this, right? So there's two ways that we recommend. You can follow an I do, we do, you do model where synchronously you have your students on the computer and you're actually guiding them through each level like I am going to be doing today. Another option is you intro a couple different levels together and then you send students off to do independent practice where they will complete all 10 levels, and then they'll come back and you can regroup and have a discussion about what was easy, what was hard, what strategies did you use, how did you solve particular challenges, were there multiple solutions that you had for different challenges, and or take screenshots of what they were doing. And Lisa actually is going to show us exactly how she implemented this. She did such a beautiful job using this method, and it was super successful for her students. And if you come up with any ideas yourself, feel free to share that in the chat so that other people can share and learn from one another. With ShapeTracer, there are goals. So in each level, I will point out the goal section. It tells the student or yourself exactly what needs to be done. There are 10 levels with different puzzles for them to solve. They will receive feedback on whether their program was correct or correct with the opportunity to make their program more efficient or incorrect. So essentially the goal is to make the most efficient program with the least amount of blocks possible. But if you do happen to write a longer code, it will tell you, oh, hey, you did it right, but you could do it with less, with a fewer number of blocks. Or go ahead.
Sorry, which is something to consider. Like the first time you implement it, do you just want them to get to do it? Do you want them to master it? Is it something you want them to go back? So definitely think about that when you do it.
Absolutely. Once they complete all 10 levels, there is a printable activity for them to use, and bots are not needed for ShapeTracer. But if they do have bots at home, if students do happen to have bots at home, if you're familiar with flash loading with the bits, there is the opportunity to use the flash loading for them to load it onto their bot and actually see the bot execute the code. And if anyone has questions about that, please ask in the Q&A and we can cover that at the end. All the blocks that are needed to complete ShapeTracer are in the left-hand panel, so they don't have to go anywhere or hunt for anything. It's all right there for them. Any speed will work in the movement block, so they can choose any speed they want, and it won't impact the code at all. And ShapeTracer 2 builds on ShapeTracer 1. ShapeTracer 1 was mainly sequencing, setting light colors, and directions. With ShapeTracer 2, we are now introducing loops. So we're thinking about patterns, we're thinking about loops, and how all of that comes together to make more efficient code. So now we're going to jump right into ShapeTracer. I'm going to share that ShapeTracer screen, and we're going to get started there. So level 1 looks just like this. So again, here's the goals menu. This actually tells you what your bot needs to do. Then everything on the left-hand panel, these are all the blocks that are needed to complete the the challenge, and then you can see that the 10 levels are up here. And again, if your students do have bots at home, this is where they can flash load and load the Ozobot. Again, if you have any questions, please use that Q&A and we can come back to that at the end and I can discuss a little bit more about that. But I do want to jump straight into the coding for those of you who don't have bots at home or your students haven't taken home bots. You can just use basic ShapeTracer, and this is what it looks like. So we want our bot to get from here all the way to the end. And first piece of advice is the top color, the light color, needs to be set before the bot moves at all. Otherwise, it won't recognize the color and the code will be incorrect. So this type light color is, go ahead, say out loud to whoever's in your room. It's green, right? So I'm gonna go to set light color and change that to green. And now I could code this all the way down the staircase in the staircase shape. But again, I have these loop blocks to use to my advantage. So I know that to get down to this first stair, my bot needs to move forward 4 steps. And actually, the reason why I know that's 4 steps, let's actually try 5 just so I can show you. 5 goes a little bit too far, and something that is that you can discuss for number sense and just math, including math, is that these gray grids, you can see that there's dark gray lines and light gray lines. The dark gray lines, from one dark gray line to another, that's 5 steps. From the light gray to light gray, that's 1 step. So I can see that this doesn't go exactly 5, it's probably a little bit less. So I'm going to set that at 4 steps and just test it. So it got all the way here. Now I know that I need my bot to rotate right. And it's gonna move forward another 4 steps. And another shortcut I'd love to show you is if you right click on any of the blocks, you can duplicate them and add that to the bottom. So I know it needs to turn right and it needs to move all the way down here. So now I'm gonna try that again just to test it. Again, encourage your students to test. I found that with students, if they write a huge long code and then test and something goes wrong, it's really hard for them to debug and to understand where they need to fix their code, and the frustration level goes up really quickly. Whereas if you encourage them to test as they're building, that sets them up for success and decreases the frustration. So here, now I know my next move is that I need my bot to rotate left this time. So here, let's just test this. So it's completed 1 complete staircase, and I know there's 1, 2, 3 staircases. So this is where I can point out to my students, it's gonna do the exact same thing 3 times. So I can pull out a loop here, and I'm gonna ask my students, does all of this need to be repeated 3 times? Not necessarily. I only need to set that top color initially, and then I can put all of that movement into the repeat blocks. So if I try this, it gets, oh, I didn't, here we go. This is why we debug as we go, right? I had it repeat 2 times, but it didn't get all the way to the end. So I forgot to adjust this to 3. And now it's made it all the way to the end. So again, it tells me that I've solved it with only 6 blocks, so this was the most efficient program. Now your students, it won't be incorrect if they put it here, because it will still also work. But for the purposes of what is going to happen in future levels, we do want to be very intentional about where we put those loops and when we set the lights, because in the next few levels, you'll see that the lights do change, and it does need to be sequential and it needs to make sense. So encourage students to be really thorough about that. Great. So we're going to run that level and we'll move on to level 2. And these challenges get quite sophisticated. So if they are challenging for you as an adult, it's going to be challenging for kids, but it teaches perseverance and it teaches really great logical thinking skills. So I know some of these had me scratching my head and I had to take a little bit of time to figure them out. So another tip I would have is feel free to split these up. You don't necessarily have to have kids go through all 10 levels at once. You could section them off and just have them do 1 or 2 a day if that works for your students. Lisa,
I was gonna say, and definitely do them ahead of time too, because you'll have the kids messaging like, help me, or whatever. And so I know sometimes I'm bad about, oh, here's a worksheet. So just make sure you've kind of gone through and seen what those bugs and mistakes are going to be, just like you do with a normal worksheet.
Yeah, absolutely. Thanks for that. Great. Okay, so level 2. This is a, you can tie in geometry here. This is a square. So we know that it needs to be read the whole time. And this is where you can talk about geometry. In a square, there are 4 sides, and 4 sides are, they're all equal, right? So I know I'm going to use a loop, because if I can write a code for one side, I can just make it do that 4 times. So I'm going to change this to 4 because I know a square has 4 sides. And again, I'm going to use those number sense skills here. I know from one dark gray line to another is 5. And then from here, from another dark gray to another dark gray is another 5. So 5 and 5 is 10. So I know that my bot needs to move forward 10 steps. And then when it gets here, it actually needs to rotate right. So I'm going to go to movement, and I will have it rotate right. And then we're going to run the program. And there we go. There's your geometry, there's your logical thinking, there's your number sense right there. In level 3, again, this is more geometry, right? This is also a square, but it's just slightly rotated. So have a conversation with your students about, this time it can't go straight, right? So it needs to go, it can't turn directly right, because then that would follow this gray path. So it actually needs to use that slight right piece of code. And again, so this square has 4 sides, but it actually has a pattern that repeats twice, because I can see it goes blue, green, blue, green. So if I can write a code for the top half, it only needs to run it a second time. So I know I can use a loop that will repeat twice, right? And the first color it's going to see is blue. So it's going to turn blue, and it's actually going to travel, that looks a little bit longer than 5. Let's go ahead and test this and see how far. Yeah, not, that was not, oh, you know what? It's because of my repeat code here. Let's actually try this. Because I said move forward 5 steps, it actually moved forward 5 twice, because it's in that repeat 2 times. So I'm going to get rid of that just so I can see what the length is. It's not quite 5. So this is where your students might have a little trouble problem solving. What you can do is you can encourage them to tie in the loop at the end, have them navigate what they think is gonna, where the loop is going to be placed, but remind them that the loop is gonna affect their code. So here it's not quite 5. I'm gonna try 8 just to see if the length is correct. There we go, perfect. So now I know that that segment is 8. I'm gonna add my loop back in, because I have a good idea of what to do next, because all my bot needs to do is it needs to rotate right. And again, this is a 90-degree angle. So you can throw in more geometry there. It's gonna turn completely right. It's gonna turn green. And I know that this segment, the green segment, is just as long as that blue segment, because it is a square. And then at the end, once the bot gets here, it does need to rotate right one more time so that it can get to that next blue piece. Again, I added that repeat to loop again in, so I know that it's going to do the top half first, and then in the second loop, it's going to do the bottom half. So here we go. Level 3. Great. Now this one is super tricky. This is the first level where we introduce the concept of nested loops. So a nested loop is a loop within a loop. So it sounds confusing, but I'm going to walk you through this. You can see that there's 2 halves of this shape. There's the yellow top half that zigzags up and down, and then there's the bottom zigzag of the purple that zigzags up and down. So that's already a loop in itself, because it's going to do the top half first, and then it's going to do the bottom half. Now, this is where it gets a little bit tricky. This top half the up, down, up, down, up, down, that's also a pattern. So we can also use a loop for that. And that pattern is exactly the same on the bottom. It's down, up, down, up, down, up, right? So it's just the same code, just used a little bit differently. So let me walk you through this nested loop. Again, the first thing we always do is set the light color. So we're gonna start with yellow. And my bot is facing straight up. I can tell because these little bumps on the back, those are the back wheels on the bot. So again, if it turns left, it's gonna be facing directly left, but it only needs to be slightly left to follow this yellow line up. So I'm going to, oh, whoops, that is the wrong block. It's gonna rotate slightly left. And then now I need to think about my nested loop. I know I'm gonna start with the bigger picture. I need to have it do the top half and then rotate the bottom, then execute the bottom half. So I'm gonna plug in a loop here. But now I need to break down exactly what it's gonna do 2 times. And it's gonna do the up, down, up, down, up, down. So let's see, it's gonna do up, down, that's 1 time, up, down, that's 2 times, up, down, that's 3 times. So I'm thinking this through. My loop is going to be 3 times for this yellow top half. It's going to now move forward 3 steps because this is approximately 3. When it gets here, it needs to rotate again to go back down. So it's gonna rotate slightly left. And then it's gonna move forward again, to get all the way down here. And then it needs to move slightly right. So I'm gonna test it right now. And again, I'm gonna actually take this loop out just to test it so that it doesn't mess with my results. Oh, and that is not correct. Let me check my code here. So it's gonna move forward. It's actually gonna rotate left here. That's where I went wrong. Okay, let's try this one more time. There we go. So I had a rotate slightly left there, and it actually should have been left because it does make that 90-degree turn. So again, testing and debugging as you go is really, really effective. Encourage your students to do that. So you can see that we've completed the top half, but now we need to get to that bottom half. So I'm gonna bring that to loop back again because repeat 2 times. But now before it does the bottom, it actually needs to turn all the way around. You can see that the bot is facing this direction. So we're gonna use the rotate. We're gonna U-turn left, and we're gonna set that light color because the light color changes. So what it's gonna do now is you can see that it executed all of this code for the top half, but now we're saying turn all the way around, turn purple, and then do it again on the bottom. And let's test that. And there we go. There is level 4 for you. All right, now we're gonna move on to level 5. So this is where we will utilize a loop in the middle of a sequence. Your students will need to identify that this red piece and this blue piece here, these will not be part of the loops. So what they need to think about sequencing and then nesting a loop in the middle of their sequence. So the first color we're going to use here is red. And it's gonna move forward. It's slightly more than 5. I can see that because it's a little bit longer than past those 2 gray lines. So I'm gonna try 6 just to test it. Perfect, I'm gonna reset that. And then now I know that there's a pattern here. It's blue, red, blue, red, blue, red, blue, red. It repeats 4 times. So I'm gonna use a loop. I know it's gonna repeat 4. And the first color is blue. So I need to use a set light color to blue. It's gonna move forward 2 steps. And let's just test that. Oh, whoops. So here we go. I did not insert that rotate button. So again, you can see I'm running into a lot of bugs. I'm testing as I go, and that's helping me. So it's moving 2 at a time. So that is the correct unit but it actually needs to change to red after blue. So I'm gonna add change the light color to red, and then it's gonna change. It's gonna move forward 2 steps, and it's gonna do that 4 times all the way to the end. Then my bot needs to rotate in this direction, which is left for the bot. And then it's gonna complete again from dark gray to dark gray. It is 5, and then 1 more is 6. So I'm just gonna copy this code from the top. Great, so that is level 5. Oh, it actually is not level 5 because let's reset that. Again, I made another bug, or I had another bug. This did not change to blue, which is why it did not pass me on. So I'm gonna pop that in there. And I love these activities because it shows kids it's okay to make mistakes. I'm an adult, I'm confident in coding, and you can see I'm making a lot of mistakes, but I'm figuring it out, and I'm using those reasoning skills. And I'm not perfect, and I think it's just so beautiful to show students that you can make mistakes and take risks, and not always be right, but you can always go back and figure it out.
And something that I think to point out, if you guys have not ever participated, definitely start with ShapeTracer 1. This one is a lot more advanced too. So make sure you have that experience with ShapeTracer 1. So I think that definitely helps.
Yes, thank you. Great suggestion. So here we have this house shape. And you might want to point out to students, this is a perfect example of what is the most efficient way for our bot to run so that we use the least amount of blocks. If we do the red first, it's going to have to travel back here, and then you're going to have to navigate the green square. So it actually, in this level, it makes more sense to complete the green square, then finish with the roof, because we have that offset roofing edge right there. So I'm going to start with green, set my light color to green. And again, this is a square. So again, you can bring in that geometry. I know all 4 sides are exactly the same length. So I know that I can use a repeat 4 times. Button here. And it's gonna move, let's see, that's not quite 10. I know there's 1 on this side that's not covered, 1 on this side that's not covered. So that's 2 less than 10. That means it's gonna move forward 8 steps. So again, you can use that number sense. I know I'm taking away 1 from 10 here, 1 from 10 here. And that gives us 8 steps. And we'll just run that just to confirm. Actually, let's rotate so that we can make sure that works. It's gonna rotate left. And there we go. So we've completed the square, and then now it needs to go up to complete the roof. So you can see that the bot is facing directly left, so it needs to rotate slightly right to get on the path of the roof. Then this is probably, let's test this and see. It's probably more than 5, but I'm not quite sure. Oh, guess what? I also forgot to change my light color again. That is a mistake I consistently make, and I'm glad I caught that one. So let's try this. It's gotten the green. So 5 was not quite long enough. I'm going to change that to 6. Let's try this one more time. There we go. And then I know this section from the corner of the square up to here was 6. This goes past that corner. So again, this is geometry. If that, we know that this length has to be slightly longer, but before it does that, we need to have it rotate left because that is a 90-degree angle. And then slightly more than 6 is 7. So we'll just test that out and see. So you can see there's a lot of geometry and a lot of logical reasoning that is involved with completing these levels. Level 7, great. Okay, this one's really fun because it has 8 sides, but you can point out to students that there's a pattern here. We're gonna use a loop, but it's not gonna repeat 8 times. It's actually gonna repeat 4 times because we have blue, red, blue, red, and it's gonna do that 4 times. So I am going to grab a repeat 4. And again, we're gonna start with blue. And it's gonna move forward. It's not quite 5, let's try 4. We're gonna try 4 steps here, and then it's gonna rotate. Again, this is not a 90-degree angle, so we're going to have it rotate slightly right. And then let's have it change to red. And then again, it's going to move forward 4 steps and then rotate slightly right. Whoops. Whoops. Again, needs to debug here. There we go. So you can see it's doing the pattern of blue, red, blue, red, blue, red, and lumping that together. All right, now we have level 8. These get very sophisticated. In this level, it looks pretty straightforward. It looks very similar to the other level we did. I believe it was level 4 or 5, where we had to start with a color, and then we did the loop in the middle, and then the color at the end. But with this level, your students can have their bot rotate and follow this in a straight line. But here's a little secret tip for you. The most efficient way to code this will involve some backwards movement so that the bot doesn't need to take extra blocks and steps to rotate all the way around. So backward is a movement that you can utilize. I'm going to show you how here. We're going to start with purple. And again, I know that the wheels of the bot are behind it, so those little extra bumps are signifying the back of the bot. I'm gonna have this move forward. Let's try 10. Let's just test it and see. There we go, we made it to the end. So now this is where, instead of having the bot turn and move forward all the way and then have to turn all the way again when it gets down to here, we're gonna utilize the backwards component. So I'm gonna have my bot rotate slightly left, which means it's gonna point up in this corner. Let's try that and just so I can show you. So now you can see it's perfectly positioned to kind of scoot backwards all the way here. And then we'll just have it rotate slightly right down here to finish off the code. So here, again, it's a pattern, purple, yellow, purple, yellow, purple, yellow, purple, yellow. That's 4 times. I'm going to use my loop to have it complete that code. It's going to start with purple, and it's going to move backwards. So this is where, instead of forward, we're going to have it move backwards about 2 steps. Then it's going to change to yellow. And again, it's going to move backward 2 steps. So let's try that and see if that works effectively. So you can see the bot is now moving backwards. And this takes less code for us to have it rotate slightly right. And then to complete the yellow at the end. And then it's going to move forward 10 steps. Now in the other level, I did have to change that top light color, but you can see in this level, the latest color that it's been set to is yellow. So we don't need to set that top light again. So let's try that one more time. There we go. All right. Now we have this crazy shape to trace. This one's super fun. We know that there's this kind of triangle shape. Again, we're going to utilize that backwards to have it scoop back and then trace the bottom of the green. So with that, we're going to start with blue. And again, you can incorporate geometry. We know that this side of this triangle-ish shape is going to be the same length as this side. So I'm going to have my bot rotate slightly right. It's going to move forward about 6 steps. Let's just test that to ensure that that is the correct way. There we go. And then again, this is a 90-degree angle. So instead of slight right, it's going to do a direct right and then complete that. We'll test that one more time. And now we know the color changes to red. And now we can utilize that backwards. So we're going to have it move backwards about 5 steps. Let's just test that to make sure that that is accurate. Oh, it's not accurate. I'm glad I checked. Here, instead of moving directly back, it actually needs to rotate. I'm going to pop in a rotate slight left. Let's try that again. There we go. And then now to get down to that green, you can see it's facing directly right. It needs to rotate slightly right to get to start tracing the green. And then we're going to complete this triangle. And this triangle looks like the lengths are similar to, or probably the same in length as our top one. So I'm going to have it move forward 6. Then it's going to rotate left because it is a right angle. Let's just double check. And it's turning in the opposite direction. There we go. And then the last step we need is to have it complete that last segment of 6 steps. So we'll try that one more time. You can see that I've tested this one so many times before actually getting to the right answer. Encourage your kids to test because they don't need to get it right the first time necessarily. This is to encourage them to keep testing, to keep iterating, to have them problem solve because this is quite tricky. All right, this one is super fun, but this one incorporates having the light turn off. So you can see this looks black, but there is no black option. So what we are going to do is we're going to utilize this new block right here, turn top light off, and that will make it look black. Where in the bot, it's actually just not going to have a light set on top. So we know, again, this is a giant square, so I know every single side is going to be the same, and a square has 4 sides. So I'm going to use my repeat loop. My bot is already facing in the down direction. I want to make this as efficient as possible, so I'm not going to have it turn. I'm going to start with this first color, which is red. And then it's going to move forward about 2 steps. Okay. And then so now this is where it gets tricky. I have red. Now I need to account for the no color, which is the turn the top light off. Then it needs to move forward. Then my next color is green. So I'm going to duplicate the block and choose green. Needs to move forward there. Then again, I have to turn my top light off to get that black color. And then my last color here is yellow. So I'm gonna duplicate to yellow, and then it's gonna move forward 2 steps. So again, this is gonna account for that first side of the square, the first side of the square, but because we have this repeat 4 times, it's gonna go 1, 2, 3, and 4 and complete that square. Oh, I'm glad I tested because I got my bot to go all the way down, but it never turned at the end. So here, I actually need my bot to rotate left. So let's try that again. Oh, I'm glad I'm testing because I am making a lot of mistakes today. Instead of slightly left, it needs to turn left. Let's see. And this is all part of the process. Huh. Let's see, set light color to yellow. Oh, I forgot the last one. So I'm glad I'm testing this. I appreciate everyone's patience here. Let's try this one more time. There we go. So you can see, even though this seems super straightforward and seems super simple, it's taken a couple attempts to actually get it correct. And your students will likely encounter a lot of the same issues and a lot of the same challenges. But that means that there's more opportunity for learning and growth for them. So those are all 10 levels of ShapeTracer. Again, you can go back and view that recording at a later date. We will have it up on our YouTube channel if you want to follow it more closely. But now I'm going to turn it over to Lisa because she is going to cover how she uses it in her classroom. And actually, just a quick announcement before I turn it over to Lisa. If you are looking for the solutions, there are a couple different places that you can find them. In Ozobot Classroom, in our lesson library, the core coding curriculum, in 2nd grade lesson 9, the solutions are there with the full lesson plan. Also, I mentioned the webinar recording will be available. We will also have our slide deck available on our webinar page where all the solutions are in the slideshow. And then coming soon, we're going to have our ShapeTracer 2 blog. So we'll have a blog post with all the different solutions and teaching tips as well. So with that, I'm going to hand it over to Lisa. Lisa, would you like me to click through the slides or would you like to present? I'm open to whatever works best for you. Oh, you're on mute.
Yeah, you can just click through. That's fine with me. So I just wanted to start out with this. That way I can kind of read my notes. So I'm good with that.
Yeah.
My students are high school math. They are struggling learners. There's all of my sections have either a special ed or an ELL tag on them, I guess, for lack of a label. So I do have some struggling kids. So I took the ShapeTracer, the first lesson that you did several weeks ago, and I was like, ooh, I want to do this with distance learning. Yeah, and I think my kids could do this, and I think it's something that would be different. And we are starting our geometry unit, so it worked perfect into that content. But also in Texas, we have something called process standards, and this actually covers probably about 3 or 4 of them at once. So I actually justify, it covers the process standards, so you can do it. As we've been doing distance learning, I've tended to do a content-based lesson and then a process standard lesson, so that they have a little bit of a break from the actual, I guess, hardcore content. So that's what I came with. So what I did first right here, and I'll have Melissa play it for you, is I just recorded my actual lesson that I gave the kids in It's Learning. So I will show y'all exactly what I did. You want to go ahead and play that, Melissa?
Sure.
So this is just, like I said, the actual lesson that I did, that I typed up. And this was a live and learn. I kind of threw it out there really quick. And I wanted to make it as easy for them as possible with submitting, because kids have issues with print screen. I mean, it's just been a real challenge. I know we've all experienced that in our distance learning. So one of the things that I made sure I did was I only made them do a few levels. And I actually was only going to make them do 2 levels, but then I realized they need a model of me doing it. I was going to make the mistake of sharing Melissa's first lesson. And I'm like, wait, that's going to give them all the answers. I don't want them, they can go search for the answers, but I'm not going to give it to them. So I decided to do the first one, which you saw, there's a video on there, and I have that linked in the slide deck for you guys, if y'all just want to look at it and kind of how I did it. But I did find out it's really important for them to hear it in your voice. So this is completely remotely. A lot of people have been asking about like joining in a classroom. Our district, we cannot require kids to come on and join with us for anything. So this has to be all done on their own time when they so choose. So I just was like, hey, let's do three, and the first one I'm giving them if they watch the video, and just kind of work them through it to introduce them to it. My students have never done anything like this for me, none. And so I think that it was something that I just kind of wanted to get their feet wet with and see if they could. And I kind of started out on that. So sorry, that's what I did. I just put it out there. I gave them 2 weeks to do it, which was way too long. I think it could have been a little bit more structured, and they could have done it in a week just for 3. But then I also made a bunch of any extra level was extra credit, because we have a lot of late work, and it'll allow the kids to not do a hard assignment maybe, but it's still testing wonderful techniques and wonderful process standards and things like that. So it was definitely very worthwhile for my kids to learn. So you want to go ahead and go to the second one? All right. So as I was issuing it and I had kids, asking me questions and stuff, I just kind of gave you guys a few tips. My big one is make sure it is accessible on a school device. I accidentally went and issued this and forgot can my kids even get to it? So definitely make sure of that. A lot of people had questions. Can it be done on an iPad? Yes, it can be done on an iPad. That's where I did my very first one on. It's not as easy, I don't feel like, but I'm also not an Apple user, so that could have been part of it. But and I sent out tips with my standard message. So on the right over here, you see a couple of screenshots just off my phone, and we are using Remind and It's Learning and email. And so I sent these little tips out after kids were asking me questions of, this is what you need to do, this is where you need to look. And I did make a mistake of saying, oh, you have to get the golden Ozobot. And I realized, this is just a learning activity. They don't have to get the golden Ozobot. Some kids are going to make sure they do because that's the way they are, like me. But I was just like, I just want y'all to try this. I just want y'all to play with this. I just want y'all to get an idea of what it might be like. And I gave them no instruction. I gave them this is all they got in their messages for the day. So if you want to go to the next one. And this, oh, I think it's missing a slide. Was there another one before that? Yeah. So these are how I did my student submissions. And I basically just said, I want to see a thumbs up or a picture of you in it because I didn't want screen sharing and sharing with each other to be sent in. So I asked them to send me like a print screen with a picture of them, which is like the very first picture I have on the video. Open a picture of you. This kid right here, if you look in the third picture, he has his assignment he submitted that week open with it. So I know that he sent it in. And then I had some feedback for you guys because I just kind of asked the kids like, what did y'all think about this? What was your idea? Because again, I gave them no like set guideline other than the lesson. I just threw it out there and they'd never done anything like this before. And all of them were positive. All of the feedback was positive. And I thought that was a really great idea. I had quite a few kids. I've had 2 kids that submitted this lesson that have not submitted one other lesson in 5 weeks. And one of them did it like the first day. And so I think that was just saying that their brains were craving something different. They really wanted something to try, something unique. And they all related it back to the Ozobots in class. And so I did like that. And there was definitely positives. So the next thing I have for you is an actual individual student lesson or student interaction of me leading him through the lesson. And I really liked this student experience because this kiddo, definitely a struggler and had never done anything like this. And so I just like that he sent it. And so you'll notice like on the left-hand side is I went through, and of course I had to pull up my computer and do the thing real quick. And I gave him like, this is what you need to do. You need to change your color first, or you need to do this first. And that was the first bit of instruction I gave him, and I kind of told him what he needed to do it. So then of course on the next level, I get another one. I need help again. So on that one, I just tried to guide him through, well, do you notice this? What should you do after here? And he then go ahead and go forward. And then he did it and was all excited and actually did another one, kind of went ahead and did a bonus one. And it just showed you that he had kind of fun with it. And he just in one level had a little bit of a learning experience and had success as something he had never done before and was very unfamiliar and kind of uncomfortable with. So I just wanted to point that out. And I thought that was a really good experience. And I like it when you have a positive feedback from something. So that was just kind of my feedback on it. I really liked it. I do recommend the first time they definitely need to start with ShapeTracer 1. I would not have them do all 10 levels. Honestly, it is a lot. And the kids that are frustrated, and some kids have 5 and 6 hours of work a night. I didn't want to do it like that. And as we were going through ShapeTracer 2, I would definitely break it up into several different lessons. Like the ones where you start going backward would be a separate lesson for me, I think, for sure. But like I said, it was just something to put out there, something to experience, and everything was positive back on it. And my kids had never done anything like this. I'm definitely going to incorporate it in next year, probably earlier on in the year, so that because it does cover our process standards, it's thinking, it's troubleshooting, it's real life. And I really like that about it. I see that somebody raised their hand and asked a question, and I would love to answer because they did it when I started talking. Does anybody know what that was so I can answer it? But that's kind of how I went about it with my kids, and I really enjoyed it. And I definitely recommend doing it. I'm going to try ShapeTracer 2. 2 weeks is too long, especially in this setting. So I would definitely do it within the week setting that we have set by our school or our district. And I would break it down for sure and give them some extra credit if you're allowed to give extra credit on something like this, because this is definitely going above and beyond in our curriculum. So it was just part of a daily grade. That's it. I hope I addressed kind of what some of you guys were looking for.
Yeah, that sounds great. Did you want to?
Oh, I forgot.
I would love for you to hear about this. I was really excited to see this. So.
Yeah. I remember this at the last moment. After the last ShapeTracer, I saw somebody post a which one doesn't belong with stuff around their house. And I'm like, that would be great for the coding. So this would be a really great way to introduce your kiddos to coding if they've never had it, and to have some different but then they're seeing the actual Ozoblocky. And I created about 5 or 6 of them, and I did them on Twitter a little bit. And the first one, me and another like certified educator and like several other people chimed in and just which one wasn't belong. And if you have never done a which one doesn't belong, there is so much thinking that goes on here. And it can come down to the number of letters in the color of the code. So this is like the first one I released, just real easy. And this is out of the Ozoblocky. I just took a screenshot. And then this one I think was my 4th one, which I haven't actually put on Twitter yet. So don't look yet, Melissa, you have to check it out later. And there's all different kinds of things that it can be if you've never done it, which one doesn't belong, you know, multiple steps versus single steps, or slow versus fast, or anything like that. And so I thought this was a really great way just to get you guys, you know, just to get my kids involved, get people involved in it, introduce others to it. Sometimes we need stuff right now to get us thinking and creating. So like when I did a webinar and I saw this had me come up with a totally different lesson that you could give in the classroom, you could give on social media, you could give in a remind, or you could just give for extra credit in your class. So I had several of these, and I'll do I guess I can do a blog post and share it with you, Melissa, or I'll share it on my Twitter. I'll just put them in there for y'all as I create them. And so y'all can use them if you so choose. So that was kind of just a way to incorporate the coding in, and block coding. For anybody that does block coding, you can really do this with a lot of stuff, but it introduces them to Ozoblocky.
That's wonderful. Thank you so much, Lisa. And I do want to highlight that Lisa has some really incredible lessons in our lesson library. Feel free to check them out. There is a short link, ozo.bot/Lisa with a capital L. She has some really cool like Harry Potter lessons, and Ozobot's mad dash to find toilet paper right now, because I know everyone's freaking out trying to find toilet paper. Just
Still.
such unique, creative, applicable, and exciting, fun lessons to do with your students. So I highly encourage you to check them out. And that is, I think we'll jump into Q&A for now. Let's see, let me click through. Oh, you know what? I have a couple of announcements before we move on to Q&A. I know a few of you have asked for social media. If you'd like a way to connect with other educators that are familiar with Ozobots, we have our Ozobot Academy group on Facebook, so feel free to join that so that you can get ideas and share and talk to other educators. If this has inspired you to create a lesson, feel free to submit your lesson to our lesson library through Ozobot Classroom. Your first lesson gets you a free Ozobot t-shirt, and if you submit 3 or more high quality lessons, you're in consideration for our certified educator program, which gives you a free classroom kit, a bunch of swag, and other fun perks. And Lisa just joined the program, and she's just been such a superstar. She can, I'm sure if you reach out on Twitter, she'll be able to tell you more about that. If you're new to Ozobot and you're interested in learning more about our 2 ways to code, feel free to go to ozo.bot/request-demo to fill out a form, and our STEAM specialist will reach out to you to get that information. And I think there's a question in the chat, Lisa, about your Twitter handle. If you wouldn't mind typing that into the chat just so people can connect with you,
yes,
that would be wonderful. I'm sure.
And I'll say it. It's at CBHS Rich Math. But I will put it in the chat as well for you guys. Let me pull that up.
And I am going to jump into Q&A. We had a lot of really, really great questions here. I actually, some of these were such great questions that I had to reach out to our engineering team to get some clarification. But one question was that somebody had an error that said the window size is too small for playing this game. So anything smaller than an iPad mini will be too small. So I don't know if this person was trying to access it on their phone or a different device, but our engineers recommend using a computer, but it will work on an iPad or an iPad mini, but anything smaller than that is too small, just because there's not enough space to see all the different elements of ShapeTracer on a screen smaller than that. Somebody asked if there was a threshold of numbers of tries to get the golden Ozobot success message. There is no limit. Your students can try as many times as they want. And along with that, I believe someone asked, what does it look like when you don't get the optimal number of tries? And let me just show you. So here.
Don't get a gold Ozobot. He's only silver.
So,
and that's another thing. I wouldn't require it be gold every time. Like, for sure. I would just say, you know, do it. Yeah.
Yeah, that's a great suggestion.
That's another lesson to me.
Absolutely. Even if you completed it in a different way, it's still right and you still met the objective, right? So here you can see I took the loop away. I'm running it 4 times. And the message says your solution works, but you can do better. Try tracing the shape or field of blocks. So it gives them a positive message, but it also tells them there's a more efficient way to do it. So I hope that answers that question. There was one more question.
I like the JavaScript one. Did you see that one?
I did, and currently there is not a JavaScript.
But there is an Ozoblocky.
But yes, in Ozoblockly, for ShapeTracer, there is Ozoblockly. What I can show you though is, let me share my screen one more time. If you are interested in JavaScript, if you go to Ozoblockly, if you build code, let me see if I have code up. I don't, but I'm just gonna go ahead and pull some stuff out. If you go on the side panel here, there is a JavaScript preview where it shows the JavaScript. Unfortunately, this is not an editor, but that's something that our team is working on to get a scripting editor out to our users who are interested in that. So that is something behind the scenes that we are trying to work on for you, and we'll follow up with our engineering team to make that suggestion for them. But there is that JavaScript preview where you can see the JavaScript code, which you could utilize this to do debugging, deconstruction of code, stuff like that. It's still super effective for that type of instruction. Let's see. Is there a way for a teacher to see progress? So currently in the state of this game, there's no like live insights, but I think Lisa shared a lot of really great recommendations of how students can share their progress with you. So I would
make it easy.
Yes. Yeah. I think those screenshots, the conversations, anything like that is your best bet to track progress. Another great question, at what point do you load the Ozobot? So let me actually show you. Because I know I mentioned it before. I'm going to turn my background off so you can actually see my screen.
I have a lot of people in the chat asking. So Melissa, at the end, you want to show that slide with our information so you can get my blog information and you can get my Twitter handle off that slide. She'll show you guys again in a little bit. Sorry, there's a bunch of them on there.
So you can see here, I have my little home office set up with my screens here. Here is my code. This is where you load the Ozobot. So I have my Evo here. I'm gonna turn it on. And the way you load this, in case you're unfamiliar with it, is that this button that says load Ozobot, when you click that, this will start flashing colors and it actually flashes the code into the bot, into the sensors, and that's how it knows the code. So I'm gonna hold it up here. I'm gonna load my Ozobot. And you can see that there's colors flashing, and then the top of my bot is also flashing green. That means it's receiving that code and that it's successfully loaded the program. So now let me see if I tilt my screen down. If I initiate my code, it should go in a red square. And so that is how you load the bot. Again, this is effective for students who have bots at home. So you can see it was successful, so that it's celebrated. But for students, you can see easily for students that don't have bots at home, they don't necessarily need it. It's a nice icing on the cake, but you can still do the instruction without it. And let me put up that slide. Were there any other questions that you wanted to address, Lisa, that came up?
In the Q&A. Somebody asked, what is the ideal number Oh no, sorry. Somebody asked like the virtual class size set. I would make it small, and it definitely depends on their experience and their age, I think, as far as doing a virtual class for the Shape Creator. I think that would have to be, you'd have to know your kiddos and kind of go into that. I think that's the only one other question that I really thought was a good one that we could answer. There are solution cards. You gave that slide as well, and you're all going to receive a copy of the PowerPoint that has the information in there. And that's it.
Yeah, great. Let me get that slide up for anyone who would like it.
And I added the Ozobot website to it too, I think.
Perfect.
So this is the information y'all are asking. My blog is for all math and everything on it is free, but I have some specific write-ups for my Ozobot lessons. A lot of them are included in the lesson library, but I've linked that in the PowerPoint slide as well for the information as well. So anything can go right here. I can send y'all my blog. And when y'all get the PowerPoint, I'm sorry, the slide, it has the information as well on the second or third slide of the webinar. It has a lot of the information.
All right, great. We have one more question. If a child uses Ozobot and shares a screen, could I load an Ozobot through screen share? Oh, that's an interesting question. I haven't tried that. I would imagine that it would be possible just because the way that the bot receives the code is just through that light flashing. So that brings up a really good point. I would test that, Melissa, just to make sure that it's effective, maybe with another educator or another student first, because that's another way that you could have your students code remotely, have that flashing light up, and then you can immediately model or execute the code of what your students have just written. So that's a really interesting thought. I love that. I haven't tested it myself, but I can see why it wouldn't work. But I would say test it because, again, I haven't tried that myself. Great. And I think that wraps up our webinar for today. I want to thank Lisa for joining us again. I'm thrilled to have you. I love the ideas that you shared, and I'm sure that all of our participants just learned so much from you. So thank you everyone for joining us today. Thank you, Lisa, for co-hosting with me.
Thank you.
I hope everyone stays safe and has a wonderful day.
Thank you. Bye.